Okay, yesterday we did a summation using sigma notation. Today we're going to use a formula called the geometric series formula, another formula given to you on your reference sheet. So a question like this, the first term of a geometric sequence is 8, and the fourth term is 216. What is the sum of the first 12 terms of the corresponding series? So if you don't know about the geometric series formula, you would have to generate this sequence to then add the numbers together. So if I put 8 first, second number, third number, and then we know the fourth number is 216. From here to here, you'd have to multiply by r. From here to here, you'd have to multiply by r. From here to here, you'd have to multiply by r. So therefore, the quotient of 216 and 8 is going to be equal to r cubed. So to get what r is, you would have to take the cube root of both sides, and that would give you r is 6 over 2. Or 3. If you put it in the calculator, it'll just give it to you as 3. So that would help you then fill in 8 times 3 is 24. 24 times 3 is 72. And then you could keep going, list the 12 terms, and then add them together. That is not going to be the preferred method. So I'm going to go right into the note card where I have the same question as our first example, but we'll use this series formula. So I believe this is 67. I did look right before. So the geometric series is the sum of a finite number of terms in a geometric sequence. So in this course, we only do the geometric series, even though there is a formula for an arithmetic sequence as well, but we're only looking at this formula, and this is the one that's going to be given to you on the sheet. The summation of n terms, or the sum of n terms in a geometric sequence is the first term minus the first term times the ratio to the n power, the number of terms in the sequence, over 1 minus r, that common ratio again. So the a sub 1, n, and r are all that we've used in geometric sequences. In a growth example that we're going to look at second, you need to add 1 to the percent as a decimal to get your common ratio. So here's the example from the do now, and we're going to find the summation of those 12 terms. So again, we have a table. First term is 8, and the fourth term is 216. That's another way that we could look at it to get the common ratio. We just did it by saying, okay, the common ratio cubed to get from the first term to the fourth term is equal to the 216, divided by 8. And therefore the ratio is the cube root, which gave us 3. Okay, another way you could do that is using those 2 points that they gave to us in a table of values. The first variable is 1 and 4. The second variable is 8 and then 216. And since it's a geometric sequence, we could do a fit growth, regression, change from a linear to fit growth. And then if you notice, I just got rid of it, sorry. Let's do it again, regression, fit growth. Okay. Here they give us the base, I'm trying to draw on it. The base, which is 3, that's your common ratio. Here, the y-intercept, isn't your first term, it's the 0th term, okay, or your y-intercept. So you can use the fit growth to get your common ratio as well. So here, either way, that was just another way to get this part, the common ratio. So if that's your common ratio, instead of using the 0th term that they gave us with the regression, 8 is your a sub 1, your first term. So I'm going to use this formula and plug in. that S, the sum of the first 12 terms, is equal to, in the formula, we start on top with a sub 1 minus a sub 1 times r to the n power. So a sub 1 is the 8 minus 8 times that common ratio of 3 to the 12th power, because we want the sum of 12 terms, divided by, on the bottom of the ratio is 1 minus the r. So in this case, it's 1 minus the 3. Ask me why this formula works. I won't be able to explain it right now, but the good news is the formula is always given to you. And if you just remember how to get the a sub 1 and the common ratio and the number of terms, you could plug into this formula, you could enter this into the calculator, and it'll give you 2,125,760. So make sure when you put that in the calculator, you get that number. Okay, so I was just using the a sub 1, the r, and the 12 terms was the n. Okay, so that's one way they could give it to you. Just ask for the sum of the first, in this case, 12 numbers in the sequence, or they could give you a summation in a word problem like this. Jasmine decides to put $100 into an account each month. So that means she's starting the first month with $100. That's your a sub 1. The account pays 3% annual interest. So that means that it's growing at a rate of 3%. So we're going to do, for growth, 1 plus that 0.03. So that gives us an R of 1.03. And they want to know how much money will she have after 1 year. So since it's each month, 1 year is going to give us an N of 12 because of the 12 months in the year. So now I'm going to plug in to that formula again. This time I'll write it because I cut it off the screen. A sub 1 minus a sub 1 r to the n over 1 minus r. My AirPod fell off. Grab it. I hope that didn't just affect the video. Now when I plug in, the sum of the 12 months is what you started with minus what you started with times that ratio to the n power 1 minus that 1.03. And again, you could just pop it into the calculator and you would get $1,419.20. Screenshot this and get this into your flipbook. I should be returning soon, so please make sure your flipbook is up to date, up to 67. I'm going to